Right, ladies and gentlemen, let's carry on with our marathon, and we're going to do the functions part now. You know, functions are good for us. I'm going to start with the easier one, and the easier one is the hyperbola, you know. So I like that one because it makes life very simple for most people. So let's do this one. I think I need this thickness will help. Let's take that thickness. Right, so this function here was quite a thing when we did it. We realized, well, these are free marks to get. So I'm not gonna go straight to the beginning when we learned about the parameter, all these parameters. Let's say we had function of x is equal to a over x minus p plus q. Remember, we learned from the very general graph. The general one that we started with was just function of x is equal to 1 over x, and we moved all the way to here. We talked about what each letter is going to do to that function. So at this point, I just want to remind you what those things were. They are not so bad because for a, we just said a was going to determine the quadrants in which we are in. So the graph of function of x is equal to 1 over x was just a graph like this. It had two arms, like this, and it had the x-axis as its horizontal asymptote and the y-axis as its vertical asymptote. So if I must remind you, the equation of the x-axis is actually y is equal to 0, and the equation of the y-axis is x is equal to 0. So this function here that is here was the function of function of x is equal to 1 over x. This was the shape of the graph, and it was just a basic graph. And we also said the quadrants, we named them like this. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we said that there were some things that were going to happen that would change this graph from being a very cute graph that it is to it will still have two arms, by the way, but where they are placed will change depending on the value of a as well, and maybe the asymptotes and everything. So to get started, I'm going to let you remember what the effect of a was. So I'm just going to write effect of in this one, just so we can remind each other, you know. So remember, we said if a is positive, just like in this graph, we will be working in quadrant 1 and in quadrant 3. The two arms will be in quadrant 1 and the other one will be in quadrant 3. If a, however, is negative, the arms will be in quadrant 2 and in quadrant 4. So what I am saying right now is, if I were to sketch the graph of y is equal to negative 1 over x, it will look like this. Quadrant 2 and quadrant 4 like this. This will be the graph of y. Let's say here it is negative 1 over x. Here a became negative in this situation, and we moved the quadrants. We are no longer working in quadrant 1 and quadrant 3, but we are working in quadrant, as you are noticing, quadrant 2 and quadrant 4. That is where your arms are at. So that is what a was doing. I'm going to talk about P and Q at the same time, actually, because we know these things. It's the end of the year. Obviously, we know these things. So what is P doing? So here we have function of x is equal to a x minus p plus q like this. I just want you to know that these were shifts. P and Q were our asymptotes. So if I must remind you, P was actually the vertical asymptote of this graph, and Q was the horizontal one. So Q was actually the horizontal asymptote. So I'm just gonna do this. It's no, here it's the horizontal. So it was the horizontal asymptote. So I'm just gonna show you now what I mean by these things. All right, so how does it work? So here, let's have an example. I'm gonna put let me maybe move slowly and showing one example at a time. So let me call this our number 1. I'm gonna say function of x is equal to 1 over x minus 3. Okay, so in this particular one, what is the a value, people? 1. What is the p value? 3. So I want you to know that the vertical asymptote is on 3. Again, I want you to know that P itself, it also denotes a shift in the x-axis. So there was a shift in the x-axis in this situation. Shift in the x-axis. Let's put that one. Let's take care of the theory so things can move well for us. So what do I mean right now? Initially, the y-axis and the x-axis were the asymptotes that were working. Now, the moment I put that -3 there, the vertical asymptote is going to move. So the asymptote is not going to stay as the y. Remember, the y-axis was the vertical asymptote. Now we're going to have a new asymptote, and we are going to shift the asymptote 3 units. And there is a thing with x. If it says minus, you're actually going to move 3 units to the right. So the asymptote is now going to be on position 3 at this point. X of 3, it's like we have shifted 3 units to the right. So the vertical asymptote is now on 3. So if I want to sketch this graph, actually, now I have to watch out that I do not, do you see my A is 1? So I am working in quadrant 1 and in quadrant 3. So it will look like this. Please, our new asymptotes at this point, in case you are not seeing it, we know the y-axis is no longer important. It's not an asymptote anymore. We can cut it. But this pink line here is, we shouldn't cut that one. And the horizontal one has not been shifted, so still we shouldn't cut this one. So when we say that we are in the first and the third, now we are really just considering the asymptotes themselves. So here, just do not touch any of those ones. So the graph that we just finished saying function of x, as you are noticing, it will look like this now. It will simply look like this. What happened? What is the difference between this graph we just finished drawing and the first graph for y is equal to 1 over x? Can you see the difference? The difference is the asymptote, it has been shifted 3 units to the right. So everything has kind of moved 3 units to the right actually. So this is the graph. So I just shifted one thing. And something is interesting here about this graph. Since we are already here, I'm going to talk about this point. What do we call such a point? That's the y-intercept. I mean, for y-intercept, we know we do just one thing all the time. We're going to make x 0. So if I want to find the y-intercept, I'm going to go to that equation, put x of 0, and I'm going to get -1 over 3. So what am I saying? This point, you can easily find it if you're serious about life. So already I have sketched a hyperbola with one thing, with an asymptote that is not the y-axis at this point. And what would be the equation of this asymptote of ours? What would you say? Let's hear from you. X is equal to 3. Thank you. So that will be the equation. It's weird. It's a vertical asymptote, and yet its equation is x is equal to 3. Let's do another example. I want you to look at these ones before I put them together. I just put a p-value this time. I didn't put, what is the value of q right now? 0, yes. Q, I have not shifted it I did not shift it up and down at this point. The graph is not moved up and down. It has only moved to the right. So I'm going to move it up and down, and that is exactly what Q does. So I want you to remember that on top of Q being the horizontal asymptote, I want you to also know that Q is going to also show a shift in the y-axis. Okay, so this one you do not have a shift in the y-axis, and it's also just what do we call it? A horizontal asymptote. So to give an example, I hope I still have space. Okay, I do. So to give an example, let me just put my y-axis here. Let me put my x-axis here. It's kind of slant, but I'm fine with it. So let me give an example of, let's say, number 2. Example number 2, I'm going to say y is equal to, why don't I still use 1 so you're not confused about life? I'm going to say 1 over x. Do you remember the graph of 1 over x? Now, what will be the difference between this one that I'm about to put? So I'm going to say 1 over x minus 1. Right. People, when we do that, what is the a value for this graph right here? 1. What is the p-value for this graph? 0. Yeah, so it means we did not shift left or right here. but we shifted up and down. And this time we shifted 1 unit downwards. And this is a horizontal asymptote. So you're gonna move from there. Remember, the x-axis was the boss before, but it's no longer. So now we only watch out for this line here. And this line is on -1. So we are not going to cut that line at all because that's our new asymptote. So we're not touching that one. And remember, the vertical asymptote has not been shifted. So this is still our asymptote right now. So when you look at these, now you can clearly see your first quadrant, your third quadrant, and so forth. So as you're noticing, when I say draw your graph, which quadrants will you draw it? 1 and 3. So now you know that my 1, you are guided by those pink lines, the asymptotes. You know that you're not supposed to cut or touch those asymptotes. So it's very easy to put those two arms of this graph on this one. So this one right here will be the shape that you have for y is equal to 1 over x minus 1. As you're noticing, this graph has just been shifted 1 unit down. This was the x-axis before, and this is the y-axis. They are no longer, especially the x-axis, is doing nothing there. As you can see, we can even cut it. So when we cut the x-axis, we are going to get a certain thing that we call the x-intercept. So this one you have to be careful, just make your y 0, right? So let's just try to work it out for this one. I'm making y 0 and I'm trying to solve this one. Look at what I will do. I'm gonna take 1 over x here and put 1 to the other side, right? Notice how I'm gonna cross multiply. X times 1, that's x. Are you seeing what I did right there? So I cross multiplied. So at this point, I know that that will be 1 and 0. So here I was putting P separately and I was putting Q separately, but you know very well that these things, when they come, P is there, A is there with a different number, and everything is there, and you're supposed to sketch these graphs. So I want us to do that right here together before we go to the questions, just to remind each other what it is that we knew back then. It's one of the easiest graphs that we actually did. I'm gonna remove all ink on the board and start all over. So I hope you have what you need. Do you? Do you have what you need? All right. Let me go now and put everything. Right. Looking at this. Now I want to put, you can put your phone on silence. It took too long to switch off. So here we have this one right here. We have function of x, which is equal to, let me do it like this. Why don't I put, it's very interesting. You can run out of ideas with these numbers. So I'm just gonna do something of this sort. I hope it's not going to be too bad. Right. So now I have everything. Everyone can see that my A, what is my A value? So what does A of 2 tell you? So you are in quadrant 1 and in quadrant 3. So what are the equations of the asymptotes at this time? Equations of asymptotes. Where is the horizontal asymptote and where is the vertical asymptote? Just so we can know that. X is equal to 1, thank you, and on y is equal to -4. That's the P and the Q, those are actually your asymptotes. And now it's time for you to try maybe sketch this one. I'm going to show you what you do to sketch these ones. So I'm going to put the y-axis and I'm going to put the x-axis like this. And I'm going to actually help you to see, when we say x minus 1, what did I agree with you? Which direction did we move? 1 unit to the right. So what it means is that we have that asymptote right here. I'm going to put it 1 unit to the right. That will be over here. That's our 1. When we say -4 here, -4, where are we moving? 4 units down. So it means our asymptote, our horizontal asymptote is over here like this. And this is -4. So it's very important to just be able to put those asymptotes in place. Once you do this, you're already halfway through what's necessary here. Because now you already have an idea as to where your graph should be right now. You do not need someone else to come and now tell you what to do. At this point, I can roughly sketch them. You see that? Let me go and roughly sketch these ones. Which quadrants am I supposed to be in? I'm supposed to be in quadrant 1 and 3. Notice I can put an arm in quadrant 1. I'm just being careful not to cut my pink lines, my asymptotes. And then on the other side, I'm on 3 again. So I'm just gonna do this. Notice how I am doing this. You see, I could sketch function of x right there. That is function of x, except we are missing some critical points. We are not allowed to just sketch this graph and go home like this. There is something missing that is really important, which is the x-intercepts and the y-intercepts. So we need to be able to find those ones. So let's go and try to find, it's actually the x-intercept that I've seen people suffering trying to get it. So let's start with it. If you want the x-intercept, people, what are you going to do? You're going to make y 0, isn't it? So they may not work out so easily because of how we got these graphs. But let's see if this is, the procedure will be the same, whichever graph you get. I'm going to take 4 to the other side because it's the one that's negative. So look at how I'm going to solve this. I like to say 4 over 1. It's good that you look first and then you can copy whatever you need later on. So 4 is going to multiply with x minus 1. Are you noticing this? And then we're going to have 2 times 1. Is that a 2? So we end up with 4x minus 4 is equal to 2, which if you are looking at this, you also see a 6, I believe. Is this 3 over 2? So our x is going to be 3 over 2, like some 1.5 of some sort. So now we have a value for this point. That'll be 3 over 2. With that point there, I mean, you will just be getting ready to get these marks, and it will not be a problem at all getting such marks if they are available. Of course, we have to find the y-intercept. If you're getting this, I can go quickly and calculate the y-intercept. There is no need to wait at all. What do we do when we want to get the y-intercept, fellow Africans? We're going to put x of 0. Notice I'm going to put 0 in place of x and say minus 1 minus 4. So this is my negative 4. As you are seeing, our y is negative 2 minus 4. Is that a negative 6? I think we are ready to write a book now. Look at how our numbers are just coming together, isn't it? So this is negative 6, that is 3 over 2. And as you are noticing, this thing is working perfectly. Please see how the asymptotes are working and how A affected everything. And now we have this graph. You already have the equations of the asymptotes. They like asking equations of the asymptotes a lot. And another thing, the asymptotes as well, and of course sketching the graph. You saw that I sketched the graph before I got my intercepts. However, you do the opposite. You get the intercepts first, and then you put them on the graph, and then you try to sketch going through the points that you have. All right. While we, maybe I should give you an example. Let's have a second. There is something else I have to remind you. Remember, I asked you about the axis of symmetry. You remember that one? These things have got what we call the axis of symmetry, isn't it? Now, let me just remind you what that was about. I know can be a lot to take in, but we did this before. It shouldn't be too bad. So we have 2 of them. Can someone spell axis for me? Is there an E here? Not an I. At this point, so we do not. Let's just carry on right now. At this point, E. Also, there is the plural one, and then there is this one. So either ways, I'll be correct. You say, okay. So people. I like you to be able to calculate the axis of symmetry given any situation. There are just 2 of them, by the way, if I may. We have 2 axes of symmetry for this one. And the good news is that there is information we know about the axis of symmetry way in advance. We already know the gradient of this axis of symmetry. It's very simple. So we're going to have two of them. The one has got a gradient of 1, and the other one has got a gradient of -1. That is all you need to remember. And the interesting part is that both of them, let me try and go and sketch them there. Let me sketch one of them. The axis of symmetry, if you recall, it will be a line that kind of cuts the graph right in half. Are you seeing that? The other half is that. They both pass through this point. The one with negative gradient as well as the one with positive gradient, they'll all pass through this point. So they'll pass through this one point where P and Q intersect. So we need to have that coordinate. If I ask you right now, what is the coordinate of this point right here? Oh, now this point, what is the x value for this point? 1, and the y value? 1 and -4. You have to take P and Q, not the x-intercepts. Okay, x is 1 there and y is -4. So I'm going to take that. Those are the points that I am going to use to find my C. I already know the gradient is either 1 or -1. The only thing I do not know is the C value. So let's go and get these things right. So here are my axes of symmetry. I'm going to put -4 here. 1 plus C is C -5, ladies and gentlemen. So my equation is now x minus 5, the one with positive gradient, the one which is slant to the right. On the other side, if I want the other one, let's say the question was asking me for the one with negative gradient, I was still going to do the same. Look at this. Is C going to be -3, am I right? So the equation of the axis of symmetry will be y is equal to -x minus 3, like so. So these right here will be the two equations for the axis of symmetry. Depending on which one you're asked, you give them. If they say the positive gradient, you give them this one. If they say they want the one with the negative gradient, you work out this one only. If they want both of them, you give them both of them. Very, very simple if you ask me. That's the hyperbola. These are the things that we were to watch out for while we were doing the hyperbola generally. So I hope I'm reminding you something here. Now, there was another thing you were supposed to know besides the axis of symmetry. You were supposed to be able to give me the domain as well as the range. So that was quite simple, actually. So going back to this one, I don't know now if you can still see the graph properly. If you wanted the range and the domain of this one, is there someone who still needs the x-intercept? I'm going to erase it. Okay, nobody needs that part. So I think I'll erase even this part. So I'm going to say, if you need the domain, life is very simple for a person who needs the domain, really. It's just the x values included. And from what we said, everything is included. You can see this graph is going all the way to the right and all the way to the left, except one x value. Which x value is that one that we are not taking? So x is an element of real numbers, but x is not equal to that value of the asymptote. The same applies to the range. It's exactly the same thing. Y is an element of real numbers, but y is not equal to the value of y where the asymptote is. And in this situation, what is the asymptote? -4. So please, people, this is precisely those are the few things I needed on the hyperbola that you are supposed to remember when you handle these kind of things. I would like, however, to just ask you to do a quick one before you do the exam paper that you have right there. I want you to do a quick one on your own so you can do exactly everything that I've just said right here. I'm going to change it to, let me give you another function. Let's say, sketch the graph of, I'm going to say gx now, -1, x plus 1. Why don't I say plus 2? Sketch this one. Give me the axis of symmetry as well. Do it as fast as you can, and let's see how well things will go. Right, guys? So obviously you sketched this one. Most of you are saying that we are sorted here. I'm just going to, can someone tell me what GX was? Because I can't work with it on the board right now. What was GX? Plus 2. Just first things first. Okay, we have a few students that are excited about the dark. What's going on, guys? What are the works of the of darkness that are taking? All right. I think I should switch on the lights. Yeah, so I can see properly. Where's the, guys, where's my vertical asymptote? There is that one child there. Where's my vertical asymptote?
On the left side.
You are right. It's moved to the left on -1. -1, okay? And where is the horizontal one? The excitement there is too much. You know, very soon I will raise it up. Don't worry, they will have their own day. They will get there. Don't worry, my dear. Just improve yours and I'll be happy. Don't send me to do bad things. What's wrong with you now? All right. So ladies, do come in. So what you need right now, I need your attention. Which quadrants are we working in? This is 2 and 4. So obviously the graph is like this. What is the y-intercept, someone? What is the y-intercept? +1. So it means the other one is kind of like this.
Yes, ma'am.
Because that is why you have to get your intercepts first. So if this is +1, then you will know where to pass through. And what is the x-intercept for those that did it? -0.5. You see how perfect our numbers are. Like I said, a book is in order here. So let me leave this one because obviously the amount of noise is letting me know that, ma'am, we understand this one, move on. Just give me the equations of give me the domain quickly. Let me just see the domain. Who knows the domain? But x is not equal to -1. And what is the range of this thing? Of real numbers, and y is not equal to 2. So it works like this, people. So what I want now, before I jump to another function, I just want to see, I was going to do the excess of symmetry and everything, but I know that you grasp the concept. So I want you to go now and do the exam paper. I'm going to give you 10 minutes to handle that one. As we are noticing here, the exams don't ask far away from what we've been doing for this function. So looking at what we have, I need silence right now. Need for you to be quiet. So looking at what we have, they can try to play around with the function. In fact, they have ways of playing around with it. If you check all our other videos, it's there when they play around with this function of x, so you do not see all your asymptotes. But in this situation, it was an easy one though, because if they want us to show that function of x is this, it looks like there is just one task to do here. Notice I can leave 1/x minus 3 as it is, but if I go on my other term, I am noticing that 2 is a common factor for that one. Can you see how this is going to end up as x plus 3, right? Yes, and then at the bottom there is x plus 3. As you are noticing, these two are going to cancel, and function of x is going to end up as 1 over x minus 3 minus 2. The moment a function is given in this format right here, we can easily see our asymptotes. In fact, they are already asking for the equations of the asymptotes right here for 5.2. What can we say if we're looking at this equation in this format? What are the asymptotes? X is equal to 3. You just kind of change the sign there, and y is equal to negative 2. These are the type of 2 marks that you should never miss at all. Now, they are leading you, actually. Look at this. They're telling you exactly what to do and how not to do it. They're asking you for x-intercept, y-intercept. Let's go and calculate those things, actually. So what do we do with the x-intercept? Anyone who still remembers? We're gonna make y 0, so we are just answering 5.3 in this situation. So I'm really going to put 0 here and solve everything. So I'm sure you gave yourself a chance to see this, because if you just let me do this, you may think that now you can do it as well. So you are going to be surprised when you are faced with your own paper, isn't it? So I hope you gave yourself a chance to do stuff like this, right? What was your x value eventually? Obviously 2x is now 7, and your x is 7 over 2. Okay, so that was the x-intercept, right? So if they say coordinates, please people watch out. At times they ask for coordinates. When they ask for coordinates, you have to really say 7 over 2 and 0. That's a coordinate. If you just leave it at x is equal to 7 over 2, that is not enough. So that's the x-intercept. And what happens if we want now the y-intercept? What should we do? We just make x 0. So I am going to go there and handle everything. So I'm going to say y is going to be 1 over 0 minus 3 minus 2. I believe this is very simple. What is minus 1/3 minus 2? Negative 7 over 3. So we would just need this value, and if you have to write it as a coordinate, this is how you will write it. X is 0 and y is negative over 7 over 3. It's very, 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 very simple. All right, so this is what I wanted from you. You obviously got your x and you got your y. Is there anyone who struggled to get these things? Yes, my dear. Mixed fractions, I dislike those, but it will still be correct. Like 7 over 2, writing it as 3.5. Yeah, it will still be very correct, but I'm seeing a camera. I don't like cameras. It didn't look to me like it. All right, so looking at what we have, look at what we have over here. Can we sketch the graph at this point? Showing all intercepts with the x's and the asymptotes. That is all we wanted to do. So I'm gonna sketch this. Oh, it seems like we have interesting sums coming. So let me sketch. I'm gonna remove everything. I hope you don't mind. You will tell me everything, because at this point I've already forgotten the x-intercepts. What was the equation? At least give me the equation. What was it? What equation are we working with? Did you say 1 over x minus 3? Yes? Minus 2, like this. Is this what we have? Okay, obviously then, if you're sketching this, 3 was a very important position for yourself, and negative 2 was not bad either, so most probably it's over here. So that's your negative 2. So you needed to sketch your graph. In which quadrant is this? So this is now your first quadrant. Just watch out for your asymptotes. And here this will be your third quadrant. Watch out for your asymptotes. I'm doing it again, people. I didn't put my intercepts first. What was the y-intercept?
-7 over 3.
And what was the x-intercept? 7 over 2. So you need these things. Y-axis, x-axis, these little things, they have to be there. And this is you sketching it, and you just have to label, is this function of x or g of x? Which function, what is the name? Okay, it's f of x, okay. So You just have to label it and then put everything, and then you have your asymptotes there. They should be continuous, okay? So make sure they carry on, and they kind of carry on all the way, so things can look pretty. All right, I would like to talk about the parabola now. It was not just the hyperbola that we did. I'm not going to be able to talk about everything about the parabola, but I'm going to say enough to get us going for the next sum. So the parabola was interesting. It's weird where to start even. I'm just wondering. So maybe what I can do, this is never a good place to start, but let me just remind you. So there was a time here, this was a skill, let me just see if you have this skill. When we were determining the equations, you're already falling behind. I'm not waiting for you. Are we together here? All right, let me say I just roughly put a function like that. That's definitely a parabola. Who is teaching together with me? It's important that I do it on my own. Can I carry on? Right. At this point, when we did the quadratic function, we knew very well that the general one, or what were we calling it again? The standard function was just like this, our very smiling graph of y is equal to x squared, a very harmless graph. This is where it's all started. We are going to talk about many things about this function, but the one thing that stands out that I think you may have forgotten by now was how to determine the equation of a given function. So we learned a lot on that one. Check this function on your own. Check actually our other videos and see the introductory videos. When it comes to determining the equation of a parabola, there were 2 to 3 things we could be given. The one thing that I emphasized on the most was when you are given the x-intercepts themselves. Let's say you are given the x-intercept and you are given this one as 1 and you are given that one as 3. They won't just give you the x-intercept, they'll give you one other coordinate. Okay? They give you one other coordinate, and at this point, let's say they just say this point here is 6, for example. And you are supposed to determine the equation of a function that is you are looking at, but you're wondering, how am I going to get the equation? Remember, a parabola will end up, most of the times, it will end up at ax squared plus bx plus c, unless, of course, if there is something else that's happening there. This is the standard form for a parabola. So what I said was, in this situation, because you are given x-intercepts, you use what we were calling the x-intercept method. So if you have that method, remember it was like this, x minus x1, x minus x2, where x1 and x2 are the given x-intercepts. So just to see me substituting into this, so it will be y here. I think if you stop copying, you may actually understand better. So notice when I put this, I do not know a, but I do know that one. Do you see me changing the sign? Yes, it was one of the things that I also asked you to realize. So here, perfect. You make your necessary substitutions. Hope I'm reminding you something. At this point, you have everything except a. You need to get a. How do you get a? Who has an idea? Who kind of remembers what we're doing here? We will substitute a point, any other coordinate that we have. Can you see any other coordinate? 0 and 6. So what you're going to do with that is that you're going to put 6 in place of y, and you're going to put 0 here in place of x. So look at how beautiful things will end up as. So this will be 6, and -1 times -3, I believe that will be 3 eventually, isn't it? And now your a is equal to? So you have solved your a value by doing this. So from here, obviously what you're doing next is to try and find the equation. So you're going to go back to this step right there, and you're going to substitute 2. So I'm saying, go and say, put a 2 there in place of a, and you're going to say x. Oh, I think I pointed at the wrong one. I wanted to say, point at this one here. So 2 there, and x minus 1, and x minus 3. Are you happy with this? So moving forward, we want to put it in this form eventually, because most of the times they say determine the equation in the form ax squared plus bx plus c. So this is what we have. So I'm going to FOIL this one with the help of sum. X times x, x squared, and then x times negative 3, negative 3x, and that one is negative x, right? So I'm going to write it as negative 4x, and when I multiply these two, what do I get? Plus 3. Very smart. So as you're noticing, the equation for this particular function is going to end up as 2x squared, and if I multiply that, that's negative 8x, and that one is plus 6. So this right here is the equation of this function. I could determine the equation of a function using the fact that I was given x-intercepts. It was a skill of yours that you had back then. There was again another way that they could ask you. Remember, I'm just trying to go all over the place. At this point, people, I know very well, I know that I don't have to go and first of all remind you how to get the x-intercepts and the y-intercepts. Those things don't change. You remember that, right? However, before I go, maybe I can talk about the turning point. You know, just at the beginning of this marathon, we actually got a place where a turning point was needed. So if your function is in this format, please, people, if your function is like this, if you want to get your turning points, remember, this is the time that we say to get x, you say negative b over 2a. And then you substitute the x value into the function to get any other thing. So say, for example, in this situation, let's say this was our function. People, are you looking at this one? If I wanted to get the turning point using the formula, I could go and say x is equal to minus, what is our b value here? Negative 8 over 2 by a, which in this situation is 2. Are we together? Don't be the person who writes what they don't understand. Understand it first. So here x is going to be equal to, you see there is positive 8 divided by 4. Here x is going to be equal to 2. How will I get the y value? Well, I'll go and substitute there. To get y, I'm going to say 2 by 2 squared minus 8 by 2. You don't have to show this one, by the way. What will be the y value for those ones that are very fast at their calculations? Looks like 8 minus 16 plus 6. What is that? Minus 8 plus 6, negative 2. Right? Negative 2. All right. So there are ways, people, after you are very smart and you're able to see things that are going on. Let me go back to the function. I'm going to show you where 2 and negative 2 is. Remember, we just figured right now using the formula that this thing is already the turning point. Are you seeing that part? Okay, let me go to the function so you can see something. If I say a point 2 here, can you see is the midpoint of these two x-intercepts? So if you already have the x-intercepts, you don't need the formula x is equal to minus b over 2a to be able to find the turning point. You can just find the midpoint and all will work. And just while we are still at it, there is also what is called the axis of symmetry for these things. It also cuts right in the middle. It's unlike the hyperbola, which is complicated. This one just cuts right in the middle, and the equation will be x is equal to 2. All right, I'm trying to squeeze in as much as I can in one thing here. Is there anyone who is lost? You can just wiggle your toe if you are lost. Or blink 3 times. Oh, I see. So please ask if you're lost somewhere, because, by the way, I think I'm doing revision, so I move at a pace of revision. Is there anyone? If not, we do not have time to celebrate much of our victory here. Let's move on. Let me show you something else. There was another situation which I just want to highlight. While we were determining equations, there was another situation. Let me show you this situation, guys, so you can be fine with life. The problem is I have assistants which I didn't hire. What's going on here? Don't worry, we will be fine. Now, can I carry on with this for now? It's more important, I feel, to carry on. I just felt let's have this one here. Very soon I'll let you be. Just concentrate for a little longer. Let's say, how many of you are looking at this point here? What do we call such a point? They can give you a turning point and then ask you to determine the equation of the parabola. So at this point, I'm just gonna use anything that I like really. I don't know, I like 2 and 3 a lot. So let me put them as the turning point. But doing that is risky because now I'm left with 1 and 2 only. So I'm just gonna say this point is 2. I hope it's going to work. At times, it's certain thoughts say we have to keep them to ourselves. So at this point, if we have 2 and 3, can you see those are the turning points? So you go via this formula. If you're given turning points, you're gonna go and we use this way. You see, I am not using the one that says x minus x1, x minus x2. I only use that one if I have the x-intercepts. Are you getting the point? So this one, I have the turning point, so I use this one. So if you watch our introductory videos, when we were doing this, you will see a number of examples on this. So notice it will work like this. Do you see that's positive 2? When I write it here, it will be negative 2, and then we square it. Remember this? And then that one is 3, and it will be written as plus 3. So just look at these little differences you see as we answer these ones. Very, very simple if you're serious about life, like I always say. Now, at this point, you can go now and substitute any other point to get A. At this point, I'm hesitating to find A because I know it's not going to be a pretty one. But let's go and substitute it. Do you see we have a point which is 0 and 2? I'm going to put 2 here and say A, and then I'm going to, you know that at this point, X is 0 there, isn't it? All right, so I'm just going to carry on like this and do stuff like that. So at this point, we are noticing that we will get A as some form of a fraction, but it is just equally fine. I'm going to say 4A here. Happy? 2 minus 3. It's not that ugly after all. Negative 1 over 4 is an acceptable A value that we can use. Now, how do we go to the position where we have ax squared plus bx plus c? Notice I'm going to take this and put it back there. You're still here, right? Let's move forward. Let me show you now that we are closer to home than we realize. I'm going to put negative 1/4 here. If you keep quiet, it may help everyone. So are you seeing this, guys? Let's give Jimmy a chance. You done saying whatever it is? Okay, now moving to whatever it is that we have to do. Are you noticing that A here is actually negative? And we actually happy. It's confirming what we knew. If the graph is concave down, obviously A should be negative. If we were to get a positive one, we're going to start questioning ourselves. People, we just have one problem here. We want to put it in standard form, so I'm just going to do it quickly. Since I say it quickly, it means I'm going to foil this. I'm not going to show every step of foiling. Everyone can foil at this point. And then I'm going to put 3 here, right? We are all happy with this. And then if I multiply that, I believe I'm going to get plus x. And then that one seemingly cancelling as well, in negative 1. And then plus 3. So obviously, at the end of the day, I'll end up with something of this sort. I believe there will be a plus 2 here. As you can see, I have the equation in the form ax squared plus bx plus c without breaking a sweat. So at this point, though, getting the parabola is quite a lot of work that you have to do as revision. But for now, with the little knowledge you have, the revision that we have done, I want you to go and look at that question you have. Because of time, I'm only going to give you 10 minutes to do that one, and then we can always go back and answer it together. Right. Even with the information that we have, let's see if we can answer anything at all in these things. So we're just gonna try and see if there is anything we know we can answer about this. The function of x is already given. I'm going to put it here so we won't be looking around for it. So it is negative x squared plus 2x plus 15. Remember though that 15 happens to be at a place for c. It obviously is the y-intercept. Can you see that this is the time when the function is cutting the y-axis? So I'm just going to put 15 here so we can make use of the information that we have properly. I can get D any time of the day because at this point, can I get D? I'll answer the questions just now, but I can't help it. I want to get D. Can you see that D is the turning point? So from what we discussed, this is what we said, minus b over 2a. Our b is very clear to us. It is positive 2. Our a is negative 1. Are we happy with this? What is our x value for the turning point? 1. So at this point, I already know that the x coordinate for d is 1. And the y coordinate will be simple to find because I'm going to go and substitute 1 into this equation here, people. So 2 by 1 plus 15. So if you can still see this, what is the value of y that you're getting? 16. So this part here will be 16. So because the function was given, you can easily find things such as the turning point. And another interesting thing while looking at this graph is do you see this line D to E? It looks vertical to me, especially if they say that this thing is perpendicular to the x-axis. Keep listening. If you have this part, if the x-coordinate for this point is 1, people, even the x-coordinate at E will also be 1 because they are exactly on the same vertical line. The x value does not change. So it was another skill that we were using back then. And you know what? If we wanted to get that turning point, there was yet another way. So just to see if you were listening to what I was saying here, are you seeing this point which is negative 3? That's the x-intercept, and this one is called positive 5. If you try to get the midpoint, you can go and say negative 3 plus 5, and then you divide it by 2. Please, people, you will still get your x of 1, isn't it? Which is exactly your turning point. Those are the things that I was mentioning. Once you see a graph, you should be able to see the few things that you can do with it should the situation arise. At this point, are you seeing that we do not have the equation of a straight line properly? But they are sharing something in common, the equation, the parabola, and the straight line. Are you seeing that they are sharing the same y-intercept? So at this point, I can easily see that this function now is going to be minus 3x plus 15 as well. Can you see that? Because it's cutting right here at the same place where we say it was equal to 15. It is actually the y-intercept for both functions. So those are the things that you can quickly see without doing much. Notice this. This is a very important statement because DE is parallel to the y-axis. Did you hear me saying that it was a perfectly vertical line? So it's I know that because I will know that it is parallel to the y-axis, so it's perpendicular to the x-axis. So those are the things that are good to notice. Let's see what the questions were about this one. So the questions were simple. You were supposed to show that k is 15, okay? You're supposed to determine the coordinates of the turning point, okay? Determine the values of x for which f is increasing. All right, so at least I have something to talk about here. When we say function of f is increasing, you see our function right here. If it's slant to the right, like so, it is an increasing function. If it's stationary, the gradient is 0. So I want you to see something here. For these points here, can you see the function is slant to the right here, all the way to that point. On the other side, it's slant downwards. So it's actually decreasing. So when they say, when is the function increasing, they're asking you, when is the function with the gradient greater than 0 or positive? At this point, this is the x value that we need. Everything from here backwards. So I'm going to say x is an element of real numbers, but x is smaller than 1. For all the x values that are smaller than 1, this function right here is an increasing function. So that is precisely what you are supposed to remember. All right, let's go and wind this question up. Let's finish it off just now. So you are supposed to also calculate the average gradient between A and D. All you need is to know where A is and where D is, and things will be fine. So let's go and find the coordinates of A and the coordinates of D. Seriously, they are all there. Can you see? So we have A, which is -3 and 0, and we have D here, which is 1 and, did you say 16? Getting the average gradient, maybe the only fancy thing is the way we write the gradient formula. In this situation, when we want average gradient, normally we just say function of x2. It's as good as y1 minus y2. Y2 minus y1. It's really the same. So we use this fancy formula for gradient, nothing serious. Can you see how I'm going to say 16 minus 0? Over 1 minus 3. So what will be my gradient for this one right here? Did you say 4? Okay, so the gradient here is +4 like this. So that will be the gradient of the average gradient between the two. Very, very simple, really. As you can see, it is actually positive, the gradient between A and D. So if the gradient is positive, it means it's an increasing function. Although this one was average gradient, it is not instantaneous gradient at that point. So this is what I was hoping you would do for those 3 marks. Let's see what else is here. You want to calculate the length of DE, people. The length of DE. It's unfortunate I have to go up and down, up and down. I hope you are managing. So the length of DE. So I'm just going to go to where D is and where E is. Can you see now that that is a vertical distance? Okay. So in case, let me remove this. DE is over here. D is over here and E is over here. So the only thing you need, because this is vertical distance, you do not have to use the distance formula. It's you wasting time if you do so. All you need is to get the y value at E. To get the y value at E, you have to ask yourself, which function is E on? It is on g of x. And we know that for g of x, the function itself is -3x plus 15 right now. So we are saying, when x is equal to 1, what is the value of y? That is what we are asking ourselves right now. So the value of y is going to be 12. Here is what I'm saying, people. You put your 12 here, and now the question is, can you find this DE right here? If you know this is 12 units high and this is 16 units high, what will be the distance DE then? Yeah, you just say 16 minus 12, which is going to be 4 units. Very, very simple if you ask me. So this is what you were supposed to do to get this distance. Let's figure out if there is anything else about this question which is interesting. We are going to stop at exactly the time we said, so hopefully we'll be done by then. If hx is equal to function of x minus 2, write down the equation. You see, this is interesting because it is like this. So let's go back to our function. I want you to see something about our function. Do you see that the equation is not given in the form? Look at this equation right here. I don't know if you can see it. Are you seeing that equation? It is not given in the form where it is already, where you can easily see the turning points. But I can change that. We can change that. Notice how that is done. So I'm going to take that equation. Remind me that equation. I'm going to go down there. So give me the equation of function of x, please, people. What was the equation of function of x? Function of x is -x squared plus 2x plus 15. Okay, here is an interesting thing. It was like this, remember? What was this point here? 1 and 16. Here is what I want you to be able to do all the time when we are faced with such problems. So write this particular one in that form. If you want to write function of x in this form that says y is equal to a x minus p squared plus q, for function of x first, I'm not answering the question yet. I'm gonna say a doesn't change. This a here, can you see is -1? Even when we go to that one, it will still be -1. But you use that p value up there. So you're gonna say x minus 1 squared plus 16. This is function of x in this form. Are you here? Now, let me finish off something here. They said something. Here they said x minus 1 minus 2. Who would like to describe this form of transformation? When you say function of x minus 1 and then you say minus 2, which transformation took place here? Where did we go? 2 units to the right. 1 unit where? To the right. And then where else did we go? 2 units down. I still want you to try and be here if it is possible. So what you're going to do is to take this point here. Are you looking at that point? Move it 1 unit to the right. Do you know the new coordinate that you get? If you move 1, 16, 1 unit to the right, what changes? The x value. So it becomes 2, right? We move it 1 unit to the right, it will become 2. Move it 2 units down, the 16 will become 14. That is all you need. So this is a new turning point, people. And to write this hx, you're just going to say there was nothing else that was done. So the a is still the same, but it's going to be x minus 2 squared plus 14. That is all you were supposed to do right there. All right. It's up to you. We are left with 5 marks, but we are out of time. Should I do the 5 marks or close? I'm gonna do 6.7 now. Let's handle the 6.7. Notice what's happening on this one. This is a very interesting sum, people. Look at this sum. Determine the maximum value of, look at this. For you to be able to determine the maximum value of something which is now an exponential, as you are noticing, this requires that you look properly. You want a maximum value, obviously, of this function. But to be able to get a maximum value, here is what I want you to see. Let me do something easy. Let's say I have 3 to the power 1. And I have 3 to the power 2, and I have 3 to the power 3, and I have 3 to the power 4. Which one will be the maximum value of these ones? 3 to the power of 4. So in other words, you want the exponent to be as big as possible. Is that true? So at this point, if we want the maximum value, it's about the exponent. We want this part here, function of x minus 12, to be as big as possible. So for that to work, you need to find the maximum value of function of x. Because if you use a small value for function of x, when you say minus 12, do you see what's going to happen? It's going to become a small number. So we want the exponent to be as big as possible. And for the exponent to be as big as possible, we need the maximum value of function of x. And please don't forget function of x is a function like this. Do you still remember its maximum value? It was at 1 and the maximum value was 16. So all you need to do for a sum like this is just to engage your brain a little, not so much. It's just you doing something of this sort. So you're going to say, since the maximum, here is the maximum you can get. It is 3. The maximum for function of x, in place of function of x, the maximum you can do is 16. Everything else will be smaller than 16. So it will be 16 minus 12. So here I'm just getting the maximum of this. And it will be, what is 16 minus 12? So 3 to the power 4, I hope is known by someone. 81. So that will be the px max. How did I figure it out? I figured the maximum of function of x because I noticed if I want the maximum value of that function, I better have the highest exponent possible. And to do that, I needed the maximum value of x, of function of x, sorry. To finish this off, I'm going to look at the first one now and say, determine the values of x for which function of x plus k will have two distinct roots. This part we talked about it as well, but I'm just going to show it again. Let me just do this. I'm going to erase this thing on the board. Should we? Okay, erasing everything on the board. It's going to work like this. So we have this part. I'm gonna just put this function so everyone can. What was the x-intercept? Who still recalls? -3 and? So it was more like this, I should think. Okay, we can go to the other function, but most of us would like to go now. Most of us are actually. So if you want to have two distinct roots in any way, this is the time when the horizontal, just remind me to call your parents, the two of you, before, they have to know that you wasted your evening. Okay, so what we were doing is to get the 2 points, just let's wind this up. Here, if you want to have two distinct roots, there are people that are, you just have to have a horizontal line that is cutting twice. That is all you need. Do you see that yellow line I put there? Do you see how many times it's cutting? At that point and at that point. But look at what we have. You have to be careful. So if I make function of x subject, notice it will be minus k. So this line here will be the line for -k and not for k. Remember, we want to solve for x, for which determine the values of x. No, do they want the values of x? Oh dear. Very bad. I thought they wanted the values of k. Determine the values of x for which function of x plus k is equal to 0 will have two. I'm sure they wanted to say k though. Let's handle it with k first so you can understand properly, because that one with x won't really work as fast as we want. So let's say it was the values of k, because that's what you need. At this point, do you see that at that particular point the horizontal line is cutting twice? Now what about down here? If I put it down here, how many times is it cutting? The only what about if I come right there? How many times is it cutting? Do I want that time? What if I come up here and put the horizontal line there? It's not even cutting, isn't it? So if we want for this to be 2 times, we can see that the value of y, which in this situation is being represented by -k, it should be smaller than 16. So at this point, the k value, obviously, that if let me change it to this because of time, because if it's x there, it's just gonna ruin everything. We were not gonna get to what we want to get to. So let's get to k there. K is now going to be greater than -16. That is what you need to solve like that. All right, people, we would like to change the world and stop global warming, but we can do it one step at a time. Enjoy your evening, okay? Right.